Hello everyone, welcome for this lecture. Today we are going to discuss the numericals on convolution, okay, for the continuous signals. So let's start with the first numerical, that is evaluate the continuous time convolution integral given below. They have given y of t equal to e raised to minus 2t u of t convolution u of t plus 2. So e of minus 2t u of t is your x of t. Okay, x of t is one signal, that is e raised to minus 2t u of t, and another signal. So this is convolution with, because what we know the formula is y of t equal to x of t convolution h of t. So x of t is e raised to minus 2t u of t, and h of t is u of t plus 2. They are given in the form of equations. We are supposed to get in the form of signals. Okay, let's see that. Okay, so now from this we can say easily x of t is e raised to minus 2t u of t. Observe, in earlier problem we have solved e raised to at. Okay, how the signal was, where a was greater than 0. Now they have given e raised to minus 2t means a is equal to 2, right, which is greater than 2. That signal will be remains the same as that of earlier numerical which we discussed in the previous class. Okay, this is your x of t then. Okay, so which is ends at infinity, that is 0 to infinity. How you got this? It is from u of t. Okay, this signal is your e raised to minus at, and it is up to u of t, that is 0 to infinity. So this is your x of tau now. Okay, and then what is your x of h of t? H of t is u of t plus 2. We know that u of t is from 0 to infinity with a magnitude 1, but they have asked us to determine this signal, that is u of t plus 2, where this is the address, it is not the name. T is equal to minus 2, means your signal starts from minus 2, which is of positive sign, okay, towards positive. This we have discussed, right? This is your u of t plus 2 signal. Now you have got x of t signal and you have got h of t signal. Now according to the convolution formula, y of t equal to, that is x of t convolution h of t. How to calculate this? We have one more formula, y of t is equal to integration of, okay, integration of minus infinity to plus infinity, okay, x of tau into simple multiplication with h of t minus tau. So this formula we have. So to get any one signal, what we have to do is h of x of tau or h of tau, both we have got. We have to take any one signal's shift, okay, and reversed, that is t minus tau, okay, which is mirror image of any one signal. You can take, usually in the formula h of t minus tau we have written. You can take this one also, because those two are, anyone you can take, it remains the same, right? So what we'll do is we'll take this signal's reverse, okay, that is shifting and reversing, and then this remains constant. Okay, observe this, this remains constant, right? Let's take this signal's mirror image, that is this one. Okay, you can observe. So this signal is from minus 2 to this side, then when you take its mirror image, then it will be from plus 2 to minus infinity. Okay, this is your h of t minus tau. Any one signal you can take. I prefer this to take. Which one is easy to reverse, that signal you take. Which you feel bit difficult or confusing, that signal you keep as it is. Okay, so now we have got h of t minus tau, which is reversed. So what I can do here is, its name will indicate this, its name, this point name is t plus 2, we can take. Okay, its name is t plus 2. Okay, yes. So what we will do is, as we said, this remains same. Let's take this signal. So what we have to do is, you have this signal and you have this signal, both signal multiplication you have to do, that is x of tau into h of t minus tau. Okay, so simple multiplication, there is no convolution here. When you do this convolution with sort of integral limits, then it will be x of t convolution with h of t. When you have reversed it and shifted, so this simple multiplication can be done. If you are getting confused with that, what you can do is which signal is constant. This signal is constant, let it be as it is. What you can do is this signal you take a conditions. Okay, according to that, imagine this you keep as it is, this you take flexible in your hand. Okay, this its name I have given, this point end, its name is t plus 2. Okay, take this t plus 2 point and wherever you wish you can place there. You just check whether those two are overlap or not. If those two can overlap, then you can identify from where to where it is overlapped and then you integrate it. Okay, this you can do. Else you place this point wherever you wish. Okay, for the according to the cases, and then what you can do is place that place this end, this is signal. Okay, where you wish, and then multiply these two, simple multiplication between this signal and this signal. Let's see how value you get and what are the integral limits also you can get from where to where. Okay, so that you can do. First case we'll take. Let's discuss the first case. That is we'll take this point as it was. Okay, it was a t plus 2 point. Okay, suppose first case is when t plus 2 is less than 0 on this constant graph. Okay, or a signal, right? When t plus 2 is less than 0 on this signal we have kept as it is. Let's place this signal, take this signal, okay, which was t plus 2, keep this signal on the same signal. Okay, or else I'll keep here. You have to check with the overlap. I'll place here. It should be less than 0. Less than 0 means this is 0. Less than 0 is your, okay, this is your greater than 0 side. So less than 0, I'll place this signal here. Okay, you can multiply or you can check overlapping. Any overlap, if you place this signal on this side, there is no overlap at all. Okay, then if you can place here and just multiply at in the first signal, this side less than 0 signal is 0 in the first signal, and in the second signal you have a signal. After 0, the signal is 0. When you multiply 0 with this signal is also 0. Signal with a 0 signal is also 0. Therefore, y1 of t, a first case, will be equal to 0. Okay. Second case will take, that is t plus 2 point. This end point we are going to place a greater than 0. Okay, we can place a greater than 0. Means somewhere here, anywhere you can place, because it is from 0 to infinity. I am going to place somewhere here. Okay, so with a magnitude 1 only, its magnitude is also 1. So I'll place this one here. Then this point was what? It is t plus 2 point. Okay, from where to where your signal is overlapped? The signal is overlapped between, observe, okay, first signal and this is the second signal. Okay, with the blue is a first signal, sorry, with the pink it was the first signal, and with the blue it is a second signal. How much it is overlapped? See, from this to this it is overlapped. That is, what is the integral between? It is from 0 to t plus 2. Okay, yes, from 0 to t plus 2 the signal is overlapped, and that you have to take and then multiply. Okay, so first signal, first case we have taken when it is less than 0, we have placed with the overlapping, or you can multiply with this. So when you multiply you get a 0. Second case will take, when you take in second case, when t plus 2 was greater than 0, I am going to place here, it should be greater than 0, right? So this place is greater than 0. It is t plus 2 point. You can place here or you can place here. Wherever you can place, it is your t plus 2. Okay. So when you are placing it, so you get the integral. Oh, how much you are overlapped? So this point was only overlapped. Okay, that is between 0 to t plus 2. So integrate it x of tau into h of tau. So take that h of t into x of t into h of t. What you are taking is h of tau is e raised to minus 2t into u of t into h of t is u of t plus 2. This we have seen in the numerical. Now what you can do is substitute the magnitude. Okay, u of t's magnitude is 1. U of t plus 2's magnitude is what? Even though it is from starting from minus 2, but what is its magnitude? It remains the same, 1. Okay, so then its value is also 1 and its magnitude is also 1. We have to substitute the magnitude 1. Then what is left here? E raised to minus 2t. We have to integrate from 0 to t plus 2 e raised to minus 2t. Integrate e raised to minus 2t with respect to tau, that is e raised to minus 2t divided by minus 2. Substitute the values from 0 to t. When you are substituting, I will take 1 by minus 2 outside, then e raised to minus 2 is there inside, minus 2t is there. Substitute the values of this, you get upper limit, okay, upper limit minus of or lower limit. When you simplify this, minus 2t minus 4 divided by minus 2 is as it is, here also it minus 2 as it is, okay, minus and minus sign, minus into minus 2 is plus 2 we have written, e raised to 0 is 1, okay. Then rewrite it properly, 1 by 2 minus of e raised to minus 2t minus 4. 1 by 2 you can take outside, then it will be 1 minus e raised to same. You can place e raised to minus 2t minus 4. This is your y2 of t. Then y of t is what? Y of t is y1 of t and y2 of t. Y1 of t is 0, y2 of t is this much. Okay, there is no need of adding all these things. What you can do is you can represent like this. Okay, we said the signal will be overlapped when t plus 2 is greater than 0. What do you mean by this t plus 2 is greater than 0? Send this to this side. Okay, then it will be t should be greater than minus 2. Meaning of that one is t should be greater than minus 2. Okay, let's solve the another numerical. They have given h of t is u of t plus 1 minus 2u of t plus u of t minus 1. This is your h of t, and they have said x of t is equal to 1, which is present between minus 2 to plus 2. Okay, so as we know, this is y of t, h of t convolution with x of t convolution with h of t. Now x of t, we'll find out the x of t. X of t is magnitude is 1. Okay, its magnitude is 1, right? And it is present between minus 2 to plus 2. It is present between minus 2 to plus 2. So this is your signal, right? So this you can easily draw. And what about this h of t? They have given in the form of equation. Let's get that how to write. Okay, so here they have said h of t is u of t plus 1 minus u of t to u of t minus 1. Draw each signal on the same line. Okay, draw each signal in the same line. First signal u of t plus 1 means first signal starts from it is from minus 1. Okay, from this it starts. This is your u of t plus 1 signal. Okay, minus 2 u of t. Don't write 2 u of t and then don't minus, like subtract. We are familiar with adding than subtracting. What you can do is, while drawing only, you draw by taking a negative magnitude. That is, the second signal is, this is your first signal, and the second signal is minus 2 magnitude. Okay, minus 2 magnitude, and it is u of t, right? Minus 2 u of t. Okay, what about the third signal? It is u of t minus 1. U of t minus 1 means t equal to plus 1. So this is a third signal, which is starting from plus 1. Okay, this signal is your, see, this is your first signal, this is your second signal, and this is your third signal. add all these three signals. Okay, add these three signals, u of t plus 1 minus 2 u of t signal, and this is u of t minus 1 signal. Add these three signals. Okay, you get this signal. Okay, from which is from minus 1, magnitude is 1, it is minus 1 magnitude. Okay, this signal we get. Be careful, from minus 1 to 0 its magnitude is plus 1. Okay, from 0 to 1 its magnitude is minus 1. We get confused or we forget immediately that its magnitude is plus 1 and its magnitude is minus 1. You be careful about this. Okay, and now we supposed to reverse any one signal. This is your h of t signal and this is your h of t signal, x of t signal. Okay, this is x of t signal and this is your h of t signal. Any one signal has to reverse. I suggest, instead of going for h of t signals reverse, I wish you to reverse this signal, shift and reverse this signal x of t, because it is from minus 2 to plus 2 with a magnitude 1. When you take a mirror image of this, it remains same, which you can see this. Okay, when you reverse it, it remains same, which is unchanged, but you have it also already you have reversed it, which is x of t minus tau. Okay, let's take this signal as a reversed. Meaning of this one is h of t is a constant. Okay, which is constant, and you have taken this signal. What you can do is write its names. This one can be written as t plus 2 and this signal can be written as t minus 2. Okay, be careful about it. It is t minus 2 and it is t plus 2. Both the ends you have to carry. Okay, both the ends you have to carry, and be careful. As we said, h of t is a constant. First case will take. Okay, first case will take. Observe, first case we can take. So t plus 2 end. Okay, t plus 2 end, let it be less than minus 1. Okay, t plus 2, let it be minus 1. Meaning of this one is you are going to place less than minus 1. It is a minus 1. Then anywhere this side you can place. This is your t plus 2 to t minus 2. Okay, when you multiply this signal and this signal, what you get? There is no overlap. So y1 of t will be equal to 0. Okay, yes, that is the first case. When t plus 2 is the less than minus 1. Minus 1 is this, less than minus 1. Anywhere you can place, I have placed here. It is. So there is no overlap or there is no multiplication. Means when you multiply, you get y1 equal to 0. Okay, observe, before minus 1 this signal is 0. Before minus 1 this signal is present. When you multiply this, you will get a 0 answer. And after minus 1 this signal is present. Here it is 0. 0 you get. And next, after 0 this signal is present, but this signal is 0. Then also you get a 0. Then this side is also 0, so you get a zeros. Okay, then next case will take, since it is a definite signal, what we can we may get more cases. Second case will take, it should be t plus 2 end should be greater than minus 1, means here. Okay, and it should be less than 0. Okay, let it be greater than minus 1, it should be less than 0, means this place. Okay, anywhere between this, you can place here or you can place here, but it should be between minus 1 to 0. When you place there, this is your t plus 2 signal, t plus 2 point. Okay, this place is there. Then how much part is overlapped? See, right, this much part is only overlapped, that is between the point minus 1 to t plus 2. Okay, so you can write the integral, that is from minus 1 to t plus 2 integration of x of t into h of t. x of t is, what's the magnitude of h of t signal, which is 1. Okay, h of t. Now what about x of t signal magnitude is 1. What is h of t signal magnitude is also plus 1. Okay, then integrate 1. So how you get, substitute the values t plus 2 and minus 1, upper limit t plus 2 minus of lower limit, which is minus 1. If you simplify, you get a t plus 3 signal. Okay, similarly we'll take next step, that is next case, that is t plus 2 is greater than 0 signal. Okay, greater than 0 and less than 1. Okay, meaning of this one is you are placing your signal between 0 to 1. Okay, you can place anywhere. I have placed here, right? Then from where to where your signal will be, overlapped from minus 1, because your signal is like this, means from minus 1 to not 0 to, okay, your signal will be overlapped from minus 1 to, observe, okay, till this much your signal will be overlapped. So from where to where it is, minus 1 to t plus 2. Okay, minus 1 to t plus 2, right? Then that time you can represent what is the magnitude. You can observe this is 1 into minus 1 magnitude. I'm sorry here. Okay, it should be 1 into minus 1 signal, because at this place, okay, at this place its magnitude is minus 1. Therefore it should be minus 1. Minus 1 you integrate, okay, or minus sign you take outside. Then if you integrate it, you get 1 only, that is tau. Substitute the values t plus 2 to minus 1. When you substitute, you may get minus of this signal, that is minus 3. Okay, and then plus 2. I have got this here. See, when you get a minus signal, you get a t minus 3 signal. So this should be t minus 3 signal. Okay, and next case we'll take when t plus 2 is greater than 1 and t minus 2. Observe here, it is a t plus 2 is greater than 1. Okay, which is from here. Okay, greater than 1 means t plus 2 should be outside. Okay, you can place anywhere, but you have other end, that is t minus 2 less than 1, means your t other end of your signal, that is t plus 2 and this is t minus 2. T plus 2 should be greater than 1, anywhere you can place after this. And remember one thing, this t minus 2 other end of the signal should be less than 1. So I have placed from here to here. Then once you place, so how much signal is overlapped? This much signal is overlapped. From where to where it is? It is from minus t minus 2 to 1. Okay, it is from t minus 2 to 1. Okay, so then what you can do is minus tau and integrated minus tau we have got, because its magnitude is minus. Take outside, it is 1 to t minus 2. Then what you can do is substitute the limits, minus sign take outside. Okay, keep aside minus sign, then only take substitute these values. 1 upper limit minus lower limit is t minus 2. So it should be 1 minus t. When you expand this, it will be 1 minus t plus 2. So it is minus t plus 3. When you are taking minus t plus 3, when you are taking minus sign inside, then it will be t minus 3. Okay, so this is your fourth case. Similarly, last case what we can do is t minus 2. Okay, t minus 2 signal, this signal, this end t minus 2 last end of the signal should be greater than 0. This is a 1. I can place anywhere. We have placed here, or you can place here also. So then what we get? So what you get is there is no overlap between any these two signals. So y5 of t equal to 0. Till this much you get. You have to verify, means shift your signals one by one, one by one, one by one. Like this cases you can do. So therefore you have got 5 cases. Then you can write y of t is equal to all these signals. Okay, which you have got this one. One thing here we have written that its magnitude is -1. I'm sorry, okay, its magnitude, not this. Okay, yes. So here from -1 to t plus 2, first signal was 1, second signal was -1. So if you do integration of this -1 to t plus 2, okay, -1 integrate with respect to tau. If you integrate minus tau, we get substitute the values from -1 to t plus 2. When you like to represent that, okay, minus sign I'll take outside, put the limit, first upper limit t plus 2 minus of lower limit which is a -1. So -1, I can write t plus 2 minus plus 1, which is minus of t plus 3. When you take minus sign inside, it will be minus t minus 3. Okay, it should be minus t minus 3 signal. Okay, next class we'll be discussing discrete signals.